Before we get too deep into solving these equations, let's just take a look at what the definition is. It's a statement that the value of two mathematical expressions are equal. So here to the left side of the equal sign, this part right here is an expression and it's equal to this part right here. Now they're not the same, but they are equal to each other. You would think of this like this. Hey, 1 plus 3 is the same as 4, or 2 plus 2 is the same as 1 plus 3. You get the idea. 2 plus 2 is different than 1 plus 3, but they do get you the exact same answer of 4 equals 4. And so that's what the expressions are. They're different, but when they are made equal to another expression, it means that there is that uniting factor, that they're equal to this one big idea. In this case, we don't know what the x is, but we know 3 times x plus 2 really is the same as 4. Okay, this equal sign says left side is equal to the right side, and that's a huge idea. And so when we go to solve these, we're going to be using something called inverse operation, and it just means the opposite. So if we're adding, we're going to do the opposite. The inverse for adding is simply subtracting. So what's the opposite of multiplying? What's the inverse for multiplying? Exactly, it's dividing. And if we came on down here, we said, well, what's the inverse for subtraction? Adding. And then what about dividing? What is the opposite of dividing? What's the inverse of dividing? Right, again, it's multiplying. Now, this term inverse, it seems weird, and all I want you to think of it is another way of saying the word opposite. Okay? Remember, we will be learning a lot of new terminology, and I need you to be able to take this new vocab and put it into an expression or an idea that makes sense to you. So if you see this word inverse, just remember it's the opposite, okay? And we're going to be referring to the opposite of adding is subtracting. The opposite of subtraction is adding. We're going to be going back to that over and over and over again. And for lesson 1, and this is where it's going to get down to it right here. We have two expressions that are equal to each other. So yes, this is an equation. 4x is equal to negative 20. Well, what is that 4 doing to the x? Well, it's actually multiplying. Over here we have negative 30 on the left side, and it's equal to 3y, or 3 times y. It's multiplying. And so when we say, let's go solve these equations using the inverse operation, that simply means, would you please go do the opposite? Now, I want to train you with where to place your eyes when you see these equations. What happens is that we want to get this x down here all by itself. See, x would be to the left of the equal sign all by itself. That's what we want to do here, but the problem is this 4, the 4 is in the way. So your eyes lock in on the variable and you go, I don't like the 4 there. I need to get the 4 out of the way. Then you say, what is the 4 doing to the x? Well, it's multiplying, Mr. Tate. Yes, that is exactly right. What is the opposite of multiplying? And that's when your brain comes back up and it goes, oh, I know this. Multiplying, the inverse of multiplying is dividing. So what I want you to do is right here with your notes, just make sure that you take your pen and very carefully, I want you to put a fraction bar underneath the 4x. Now, this is actually going to be used as a division symbol. Since 4 is multiplying x, we're going to take whatever this number is that's multiplying against the variable, and we're going to write it right on the bottom. Okay? Now that means 4 is going to be divided by 4, no problem. And then whatever we did on the left side of the equal sign to make that 4 go away, we're going to do the exact same thing over here, and we're going to divide it by 4. So 4 divided by 4 is 1. See, and we can put a 1 there. Remember how we've always talked about creepy 1 is always lurking. And so now we're going to erase 1 because we really don't want them there. And you can see that this x comes straight down. Now what is negative 20 divided by 4? Negative 5. And now we actually know what the solution is to this equation. The x has to be -5. If you pulled out your calculator, you could actually type in 4 times -5 equals -20. Now I just put the -5 in parentheses, that way we can see it's multiplying the 4, makes it a little easier to read there, but 4 times -5 is indeed -20. This is the answer, okay? And so now we just have to go and do the exact same thing. When you look at these equations, you don't get concerned about left side or right side. What you do is you go, where's the variable? Right there. And you ask yourself, hey, what do I need to get away from the variable? Well, in this case, it's the 3, right? What's the 3 doing to the y? It's multiplying. What is the opposite of multiplying? What's the inverse of multiplying? Dividing. So since it's a positive 3, I'm going to divide it by 3. Boom. The y is free. See how the y just comes straight down? But what do I have to do to the right side? What we did to one side of the equal sign, we have to do to the other, so these two sides stay the same. We just divided this side by 3 to get the y by itself. So let's divide this side by 3. -30 divided by positive 3 is -10. Now in your brain, let's go play this out here. -30 would equal 3 times y. Well, -30 is going to be 3 times whatever we said y was. The y is -10. Is 3 times -10 equal -30? Yes. So we know that we've solved this equation. Now, this part usually goes very, very nicely until we start introducing a few of these others that kind of scare people the first time that they see them. I don't want you to be scared though, okay? The first thing that you do when you see these equations is that your eyes lock on them and you simply go, where's my variable? There it is. There's the m. I need to get that completely by itself, okay? So then you say, well, what do I need to get rid of? Well, in this case, I need to get rid of the 3, okay? I need to get rid of the 3. What's the 3 doing to the m? Well, up here, when we drew, whoops, a little too high. When we drew this line right here, and we put a 4 underneath it, it was 4 divided by 4. This was showing division. So when we come down here and you see this little fraction bar right here, it's really m is being divided by 3. What's the exact opposite? Excuse me, what's the inverse of division? Multiplying. So what I want you to do is I want you to put a 3 right here in parentheses, and that's going to show that we're going to multiply the left side by 3, and it's going to cancel it out. The m is free to drop down, but now we have to multiply the exact same thing to the right side. See how we just multiplied by 3 in parentheses? Put it in parentheses right here, and we get -6. Look how it works out perfectly. See, look, m is being divided by 3, and it's supposed to get us -2. Well, that m is going to become a -6. What is -6 divided by 3? Well, it's equal to -2. It really does work. We're using inverse operations to get the variable all by itself and be able to show us what that variable needs to be to keep the two sides of the equation equal to each other. So here, again, it's not about left side or right side, it's eyes on the variable. Gotcha. What do you need to get rid of? In this case, it's a -6. Cool. What's it doing to the e? It's dividing. So how do I get rid of division? Well, the inverse of division is multiplying. Take whatever's here dividing on the bottom, put it in parentheses right there, cancels and the e drops down. And then do the same right over here to this one. -6 times -30 is 180. And so as a result, we know that this equals 180. Let me go through and actually fix this one right here. There we go. M equals -6. And in fact, one of the things I'd like you to do is just make sure that you're always boxing in your answer with the variable by itself equaling to what it's supposed to be. That way it's a lot easier for the person grading these papers.